Welcome back to one more session. Today we will be discussing about the assessment of visual environment. We discussed about thermal. Now once we are in a closed environment, we are working in a particular workplace, the physical environment is very important, because that has a direct impact on the performance level, your motivation, your energy system and all those things. So, when we are talking about the whole physical environment, visual or lighting environment is very important component of it. So, today we will be talking about that particular area. So, let us understand what it is. So, visual environment is a single integrated user environment that caters to the engineering simulation needs. Okay. So, lot of engineering simulations are important across major industries. Okay. So, when we are talking about visual environment, it is a single integrated user environment. So, when there are several fixture, several sources of light, everything we will be considering together as a single unit, and then we will be talking about the how those environment, the visual factors are affecting. So, we will be discussing all those things and how we can measure them, what are the varieties of utility of it, we will be discussing it today. So, it is consisting of two elements, one is objects being viewed, another is lighting. So, object is viewed, suppose you are holding a particular pen. So, this may be the first component, that is the object you are going to viewed. Now, this is a pen. Now, the second component of visual environment is the lighting. What is the source of light? Now, in a particular dark room, if I hold this black color pen, then I may not see that. So, viewed object is present, but light is not present, then I cannot see anything. Now, in a illuminated room, there is no object. So, I cannot see that. So, there is no visual like feeling or experience, right. So, to have that experience, always we need two specific element, one is one object which we are going to see, and another is the source of light. So, it can be daylight, it can be an artificial light. So, the visual environment can be studied in three different categories. One is spectral, which deals with the wavelength of light. Second is temporal, where we are talking about changes over the period of time, and spatial, which is related to the space. I will explain each separately. So, let us talk about the spectral aspect. So, it is the effectiveness of electromagnetic radiation in producing the sensation of vision depend upon how sensitive the eye is to the wavelength present in the current environment. So, when we are talking about the effectiveness of those electromagnetic radiation, that is the spectral aspect of the visual environment. The spectral characteristics of the light and the weighted sum of the radiation present at each wavelength determines the amount of light present in the environment. The spectral sensitivity of eye for daytime light levels known as the luminosity function. So, which is very important, because this luminosity we are going to measure, we are going to analyze, depending on the requirement we will be doing the modification of it to achieve a comfortable work environment. The sensitivity of nighttime light levels away from the artificial source are known as the scotopic luminosity function. So, when we are talking about daytime, it is luminosity, and when it is at night time, we are talking about the scotopic luminosity function. Now, let us understand what is the temporal aspect. It is very clear, it is related to your time travel, right. So, what is the temporal characteristics of light, maybe when it is at night time, when it is at daytime. The same light source may be 100 lakhs light which is present in the environment. At daytime it will function differently, at light time it has different impact. Okay. So, once we are talking about those aspects, it will be considered in the temporal aspect. So, the visual system integrates light over a finite period of time, and a light flickering faster than the integration time will be perceived as a steady rather than flickering light. So, this is very important. So, mostly it happens with the artificial light source. So, when this source of light from that particular point where the light is getting emitted, so if there is a time gap and the eye can understand that gap, there will be a flickering. But when that gap is negligible, the eye cannot understand or sense, the eye is not sensitive to that, then I will find it is a steady light. So, based on this principle, there are so many systems available or equipment available which try to understand your mental workload or the status of the current working environment, which is the impact of visual environment on your performance. So, there are instruments. Okay. So, integration of time varies with the light level as well. So, that also we need to understand and then we can take action of it. Now, let us understand the third component, that is related to the space. It is a metameric match and it has two component, that two object. In this particular case, we will be talking about only the light source. So, it appears to be identical in color even though there is spectral composition are different. Suppose there is two different light source, but on a given point of time, given a situation or given a space condition, both will look similar or same. Why this? So, this will be considered in the spatial aspect. So, human visual system is wonderfully adaptable in nature and it operates over a wide range of ambient light level. This is very important. So, take example. Now, when all of a sudden at home we get load shedding, then what happen? We try to understand with a very less amount of light where the positions are, locations are, and then we try to analyze that. So, now if we are talking about the lighting environment of a particular workspace, how we can design it in such a way that over a period of time, like daytime, midday, and then maybe in the afternoon, and then at the evening, how the light sources are managed, so that your visual performance are not getting affected. So, when we can do that, we need to understand the spatial aspect of it. So, the eye which has two different types of photoreceptor. All of us know, if we read about the anatomy of eye, it is rod cells and cone cells. So, which actually detect all the it receive the signals and it creates an image, and then finally we can see them. So, that is the very important component of eye, which help us to understand light and understand or view the object in front of us. So, once all these systems are available, let us understand why these measurement systems are required to do, like why we are doing all these visual measurement, measurement of the visual environment. First is health and safety. When we are working in a poor illuminated condition, it may affect the health of the eye, and over a period of time it may cause and damage to your eye function. Okay. So, that is why it is very important, visual performance. So, as far as accuracy is concerned, it is very important to measure the lighting sources, the various variables of the lighting environment or illuminated area. Take example, when we are talking about some very critical job, maybe watchmaking industry, maybe diamond setting of a particular jewelry industry or ivory industry, where fine tuning is very important. There you need lot of visual concentration where illumination plays a big role. That illumination, it should be in such a way that it helps to improve the quality, it helps to improve the work of that particular job, or maintaining to minute delicacy of that particular job. But at the same time we have to take care that there is no negative effect from the light. So, if you can all do that, then our visual performance definitely will improve. So, that is one important aspect. Definitely aesthetic is very important when we are talking about the light like visual environment measurement. So, color of your workplace, color of your clothes and all those other aspects. So, it is mainly related with the well-being. So, let us understand how we talk about the amount of light. So, amount of light will illuminate a surface more dimly if it is spread over a larger area. So, we say that illuminance is inversely proportional to area when the luminous flux is held constant. So, a typical amount of exposure if spreaded over more area or the area of exposure is more, then total illuminance level will go down. So, 1 lux is equal to 1 lumen per square meter. So, we call it Lx, that is the lux. Unit name is luminance and it is a SI derived unit. We represent it as Lx. Okay. What is illuminance? In photometry, illuminance is the total luminous flux incident on a particular surface per unit area. So, here you can see if this is the light source and this is the target surface area, now all the lights are coming and floating here, then we will be calling as the total luminous flux incidence on the surface, that is the lumen per meter square, or it is lux. So, that we will be calling. So, this particular area we will be considering. So, it is a measure of how much the incident light illuminates the surface, wavelength weighted by the luminosity function to correlate with the human brightness perception. So, this brightness perception, of course, it varies from person to person, but this illuminance measurement is constant for everyone, because as it is a physical measurement, it is a instrument measurement. So, you can it is the constant, but the perception of that may vary from each person. So, illuminance unit, it is a SI derived unit. These are measured in always as lux and equivalently in lumens per square meter. We have CGS unit for this particular illuminance also. We call it foot candle or fort, and it is equal to the 10,000 lux. The foot candle is a non-metric unit and mainly it is used in the photography section. Okay. So, these are the variable or nomenclature we are always going to use and we are going to measure whenever we are talking about the visual performance on the assessment of the visual performance in a particular workplace or work environment. Now, based on different empirical studies and different requirement, there are several standards and guidelines which says if the work activity is this, your requirement of light is this amount. Okay? But it keeps on changing because there are lot of contextual issues. So, there are broad guidelines. Here also I mentioned only 6-7 of them. So, you can say if it is a place where people rarely visit, that is not much important, like there is no such activity which is very crucial to do, only walking, talking to understand what is the position of these things, maybe those cases 50 lux is more than enough. But at the same case, when we are talking about the office environment, where we have to read the document, we have to answer to something, we have to do some critical job, those cases it is 500 lux. How the criticality of the work environment keeps on increasing, the demand of light or demand of visual environment keeps on increasing. So, if it is a critical visual job, then definitely you need more amount of light. Okay. So, that way we have different standards, every country has their different standards, although on an average these are same, but still when you are talking about the requirement, it is quite context based. So, especially for the designers who are trying to develop something for the visual field of a particular workplace, you need to understand the context requirement, and then only you can decide what is the possible or correct amount of light is required for that particular activity. You really cannot generalize them properly. Okay. It's not very general. Okay. So, based on the context, the amount keep on changing. Of course, through experiment you can justify why this amount is this, why this amount is not that. So, suppose in a particular work environment where you need a particular amount of lux as for that particular job, you need to do lot of experiment to establish, yes, this amount of lux is the optimum for this type of job, and maybe it is not being reflected earlier anywhere. Okay. So, you really cannot generalize it always. It is possible for like school, when we are talking about classroom design. So, there are general guideline there that you may accept. If you are talking about designing of a office environment, maybe there are specific guidelines are available, but within office on a particular desk, if some specific job is to be done, that you need to identify, because that instrument, that particular operation may need different amount of light resources. Okay. So, that experiment you have to find out through your interest. Okay. So, that is the case you should always refer. Now, when we are talking about all this, so luminous intensity we should also understand, especially in photometry. Luminous intensity is a measure of the wavelength weighted power emitted by a light source in a particular direction per unit solid angle based on the luminosity function, a standardized model of the sensitivity of human eye. So, this is luminous intensity. It is a measure which describes the amount of light emitted by a particular point source. So, when we are talking about source of light, so when we are trying to measure that, this is the luminous intensity as the variable we are going to measure it. So, we have a particular unit for it, we call it as candela, and it is an SI unit. Now, we have luminance. This is also very useful variable when we are talking about visual assessment of visual performance at workplace. So, luminance is a photometric measure of the luminance of the luminous intensity per unit area of light travelling in a given direction. Very important. So, it is a vector, it has a particular direction. So, when we are measuring that of luminous, we will be calling it as luminance. So, it describes the amount of light that passes through, is emitted or reflected from a particular area, or maybe falls within a given solid angle. So, it also has an SI unit, and we take it as the candela per square meter. Also, we have some CGS unit, but SI unit is more frequently used unit in this particular field. When we are talking about all those things, we need to understand there is called very different or very common phenomena is reflection, and it is reflectance is related to reflection of light, and it is related to your visual performance. Slowly we will be taking you to the glare and all. So, let us understand first what is reflectance. So, it is expressed as a percentage and states how much of the light falling on the surface is reflected back. So, some amount of light is falling on that particular surface, and few amount of light is getting reflected. So, when we are trying to measure that, we will be using reflectance. So, measure of the proportion of light and other radiation striking a surface which is reflected off it. Okay. So, some amount is coming and some amount is going back. So, when we are trying to measure and understand these variables, we will be talking about the reflectance. Again, the kind of unit here we will be using as the candela per square meter. I tried to mention earlier also about the flicker, because flicker is very common phenomena when we are talking about the light source. So, we call it as the noticeable rapid fluctuation in light level. So, when human brain can perceive the changes in the level of that particular light, then we will consider it as a flicker. So, mainly it is associated with the artificial lighting. So, the visual system is very sensitive to flicker, which is related to its sensitivity to movement, both of which are changes in visual scene over particular period of time. So, objective measurement of flicker is simple because it requires rapid response equipment. So, I can see a flickering in the particular source, but how do I respond to it? So, because that needs lot of alertness of human body. Okay. Also very high level of instrumentation. So, these things are not very simple, and we have different types of instrument which use this particular feature of the lighting environment and try to measure different other physiological variables of human body to talk about fatigue, mental alertness and all those things. So, when we are talking about light, color comes automatically. Without discussion about the color, we may not complete the understanding of the visual performance. So, what it is? Sensation which can be a powerful tool in the design of any particular display, we take it as a color. So, it may be defined in terms of hue, saturation and lightness. So, let us understand all these three terminology. What is hue, what is saturation and what is lightness. So, hue describes the perception of color. For example, I perceive this color as black, I perceive this particular bottle cap as blue, something like that. Okay. So, saturation describes how dark the color is and lightness describes how bright it is. So, visual performance can be improved by using color to provide a contrast between a task and its surrounding. So, that is the way how you take care of color in any particular design of the workplace environment. When all these things we are considering, very important factor which has impact on the performance is glare. So, let us understand what is glare. So, it is like there are two different lighting related visual problem which are related with glare. One is discomfort, another is reduction in visual performance. So, these two things like discomfort and reduction in visual performance we group together under this glare category, and these problems have in common the fact that they are the negative consequences of light. Very important, these are the negative consequences of light. Till now, whatever we were discussing, luminance, luminosity and all those things, it helps human being to see the object, perceive the object, understand the color, work on and all those things. But when we are talking about glare, it has the negative impact. Because of light, how human performance is getting affected. So, let us understand these two components, that discomfort of glare and the reduction in visual performance. So, discomfort of glare. Visual field has a much higher luminance than its surrounded. A feeling of discomfort may occur around your eyes and your eyebrows, because if it is very high, the muscles, that other part of your and the anatomy of the eyes will not be work properly, and it will create a discomfort of your feeling, of your perception. So, that cause discomfort glare. So, discomfort, it keeps on increasing if the increase in the luminance of glare source happens, and an increase in the angular size of the glare source at the eye level. So, if that happens, that your discomfort level keeps on increasing, but it will decrease with the increase in the luminance of the background, not on the source, and an increase in the angular position of the glare source relative to the line of sight. So, whenever we are discussing, whenever we are talking about glare, we need to and redesigning of the workplace, the main point of intervention will be the line of sight, because how that is related to the source. So, if we can adjust that, of course, we will be able to reduce the glare, and if we improve the background light, that also will help to decrease the glare. So, if glare decreases, ultimately our performance will improve. So, that is the fundamental concept we try to follow. So, being like when designer talks about the working in that particular or modification of a particular workplace environment, we are actually working with the background light, and we are actually working on the how that glare is related to the line of sight, that we need to understand and work. Now, disability glare. Disability glare is the loss of retinal image contrast as a result of intraocular light scatter or stray light. So, it reduces the disability. To reduce this particular disability, one should raise the contrast between the task and the background. It has been described as a reduction of visual acuity caused by light elsewhere in the field of vision. So, you want to see a particular object, there are so much of other background light and other sources of light, so that you cannot look at that particular object. Okay. So, that your eyes cannot create that particular image. Okay. So, once these things happen, that is called as disability glare. For example, I will take one example, like when you are driving at night, some car is coming from opposite side and the headlight creates a discomfort glare for you. Okay. Some diamond worker who are working, and there are task light which is getting reflected by the surface of the diamond sometime, and it creates a discomfort glare. Okay. These are the cases where we need to really work how the background light and source light can be adjusted, and we can properly illuminate the task area. Directionality of light is also one of the area what is have an impact when we are talking about the visual performance. So, the luminous distribution of the luminaires has a strong impact on the modeling ability of the light and the contrast in that particular scene. So, it can also be used to reveal a relief and as a means of directing attention, because when you are talking about light, so always your eye look at that, Okay. So, it creates its drag your attention, it drag your looking pathway, and it helps us to understand how I am working in that particular visual field. So, the more direct the light, higher would be the contrast. Light striking an object under an angle will emphasize its form and texture at and more than it is a diffuse light, and then it will appear differently, and then it may create lot of disturbance in the whole visual environment. Okay. So, artificial light generally has a higher directionality than daylight. Of course, daylight has only one typical source, it spread uniformly approximately, but when we are talking about artificial light, its position, its intensity, its orientation matters a lot. Okay. So, there lot of issues need to be take care when we are talking about the directionality of light. Now, when all these things are coming, daylight, understanding of daylight and then utilization of daylight for designing is very important. So, daylight provide spatial and spectral variation within a particular room over decreasing the monotony of the environment, because over the period of time it keeps on changing, over the period of environment it keeps on changing. So, the illumination variation might be quantified as a change in daylight factor across a particular room. So, a daylight factor is what? What is this? So, it is a ratio of illuminance from the skylight measured on a horizontal surface within the room to the illuminance from skylight measured on a horizontal plane, which has an unobstructed access to the hemisphere of the sky. Of course, it needs lot of mathematical calculation. So, if somebody is really going to work on these small factors, we need to understand. Suppose many cases we want to improve the daylight condition of a particular work environment. So, in that case these calculations are very important, and how we are going to locate our windows, how we are going to locate our door or holes or some entry point at the maybe at ceiling, we need to decide on that, and then we can improve the condition of daylight of a particular closed room area. So, measuring the visual environment, we have varieties of standards and we have guidelines. As I mentioned earlier, although there are standards and guidelines available, based on the context, based on the design need, it may change slightly. So, for your own objective, own research area, you need to develop that specific criteria based on specific amount of instruction. Okay. So, maybe you have a guideline. So, if it is an office area, approximate lighting may be 500 lakhs, but is it general for all types of office? Definitely not. So, what is the work people are doing over there, based on that you can do a changes, you can do an experiment and you can publish that particular data for further references. So, what measurement we should do? For that we have very specific two situation. First is design situation, where the concept discussed previously will have to be considered in a somewhat abstract manner. Okay. Whatever we discuss, luminance, illuminance and all these concepts, we can use these values in an abstract format. Second is the more immediate practical case, where we have a particular environment, we want to know is it, what is the condition. So, you have a lux meter, you have varieties of instruments with you to tell this is the current condition of the current working environment, you go and measure it. So, that is the situation. So, in the first case you have a range, you can fit your design, your solution within that varieties of range, within that particular range. But in the second situation, you are just trying to evaluate, okay? You are trying to understand that is it good, bad, or it is not acceptable. So, you have to measure it, you have to give a specific value, and then you can compare with the standard or guideline and say yes, this is the condition. Okay. So, this is the two types how we measure and what are the situation, how we actually use these variables for more experience. Now, here when we try to measure any light level or illuminance of a particular area or room, this is the standard or referred points we should measure. So, if it is a small room, then the points to be measured are small. If it is a bigger room, sources are different, because maybe it is a only single source, maybe different sources. So, if the sources are different, then you have number of points of measurement will be more. So, this is the specific guideline we try to follow. Now, here suggestion is, suppose you are finding a particular room where it is near to this is in between this particular junction. There will be a question, shall I measure 9 point or shall I measure 16 point. So, what I should do? The suggestion being a researcher would be, depending on the use of your data, you should decide which are the number of points you are going to measure. Depending on the understanding what is the utilization of that particular collected data after you collect them. Is it going to design something? Is it going to refer something? For what? So, based on that you should decide. Now, again it may happen, still there is a question, especially for the new researchers, many times there are many questions that why not 16.5 or 9 points. So, always it is better if you have a question, you go for the higher values. Okay. So, you will definitely have more detailed data. So, it is not a problem, but if you miss some point, then there is a problem. So, always you try to go for a higher value, like higher number of data collection. So, when we start doing the measurement of the visual performance of a particular workplace, so mainly understanding of the light level or illumination level of a particular environment, let us understand some kind of very specific checklist. So, if we are talking about the luminance and illuminance, then we should understand where is the light needed in a particular workplace. Suppose this is the work desk I am currently working. So, is it required to enlighten this work desk or somewhere else? So, what the variation is available there? Is it required across the room or is it required across the workplace? So, if the supplementary light needed anywhere, then at any particular time of the day is it required, or at particular time of year it is required. So, varieties of checklist you can follow. So, if it is about a surface, then let us understand what about is it about wall, is it about ceiling or floor. So, what are the reflectance ratio between all these. So, am I going to answer all this? So, these are the checklist you can follow. So, now if we are talking about glare, is it a discomfort glare or is it a disability glare? If it is a discomfort glare, is it a problem or it is something else? So, if we try to understand all these things, we have relevant questionnaire, relevant set of instrument which will help you to evaluate them and finally decide that what should be the work environment, how you can analyze that and how you should recommend that working environment as far as visual performance is concerned. So, for temporal aspect also you can see that in the visual task itself, for example, in a computer screen. So, is it within the computer screen or not? So, how it is happening? So, these are the checklists. Now, when we are talking about all types of these parameters, or we can say variable like luminance, lux and all those things. Then after analyzing or after understanding how it is related to the human body, how it is relevant to the performance. So, of course, when there is a negative impact, especially the glare is present, your performance will be hampered. How much, that you need to decide or define for your case through different experimental study. When we talk about visual performance of a particular workplace, one very common symptom comes into existence is the work related visual strain. At the beginning of the understanding of visual performance on and lighting, the relation of all these things, this particular disorder or difficulties used to terminology wise, it was computer vision syndrome. But finally, through various study, we came into a decision it can be for any visual activity at any illuminated space. So, what are the varieties? It can create eye strain, it can cause headache or spinning head, blurred vision, dry itchy eyes, neck and back ache, light sensitivity, double vision and many other problems. So, there are several checklists available, there are very standard questionnaires available which really evaluate that is there any work related visual strain available or not. So, if it is there, then you really need to go back and check what is the visual environment, special, that means the lighting environment exist in that particular workplace. So, today I thought of discussing all those things. Now, these are the measurement instruments. So, lux meter, I think I explained this one in the very first few lectures, maybe first week lecture, that how we measure the lux illuminance. So, that is the lux meter, photometer, we have critical flicker fusion apparatus to understand the flickering of the light and all those things. And this is the again a very important book which you should refer while studying all these variety and all this type of assessment of visual environment. Okay. So, if you have any query, write back to us. Thank you.